So I hope I am audible to everyone and the screen is also visible. And yeah, as usual, let me know if anyone any doubt in between. Just put your question in the chat box, right? Or if you want me to unmute you, just let me know in that case, because I think I have muted all of you. You might not be able to unmute yourself. So yeah, if that is the case, I will allow you. So to start with, now I hope you people have gone through the last session recording. Okay. So if you remember, or those who are present, or those who might have gone through the last session, they will notice that we have talked about seaborne, right? So we talked about seaborne. So this is the topic which we are trying to talk about. Last package. This was the last package among the packages which we started with, right? So we started with NumPy package, right? Just to revise the things. Then we have seen pandas. Then we have seen matplotlib, which is for visualization. And the last package we started with was Seaborn. So in Seaborn, we have seen distribution plots, categorical plots, and matrix plots. What I will do today is I will finish with remaining three IPY files. Okay, maybe half an hour it will take. Let's see. So after this one, I will go and I will try to talk about the first algorithm, and that is nothing but linear regression, as mentioned in the syllabus. Linear regression. Talking about C, these two things you already covered: basic definitions and types of learning. Talking about hypothesis space and inductive bias, evaluation, cross validation, all those things will be covered in linear regression itself. Okay, right? Because I will be providing you some notes in which you will get everything about these things, right? So those who have gone through all the lectures, all the sessions till now, or who have attended all the sessions, they might be knowing that we already discussed these things. We started with the packages, and these things, if you talk about these things, the first point, they will be covered during linear regression itself. Okay. So today we are going to start with the concept of linear regression. First of all, I will be talking about the concept of linear regression, and then I will show you the implementation with a simple problem statement, right? Or maybe a mini project kind of a thing, or we will try to create for application. We will try to create with the help of linear regression. Okay. So first of all, as I said, let's finish with the remaining things. What we have seen in case of C1, which is for visualization, we talked about distribution plots, right? So if I open this, you will just remember whatever we have seen. These are the types of plots we have seen: distribution plot, joint plot, pair plot, rough plot, and KDE plot. So this file is available with everyone. I hope you have gone through this particular thing, right? So this is what we have seen in case of C1. That was the first point, the distribution plot. After that, we talked about categorical plots. In terms of in case of categorical plots, we have talked about factor plot, box plot, violin, split plot, swarm plot, bar plot, and count plot. So I have given you examples. I have given various examples for all these types of plots. We have talked about the reason behind why to make use of this plots, right? So box plot, I told you this is something important. We have discussed in detail about the box plot. There are different terms which you are going to come across again and again, like there is something called as hue, there is a number of beans, palette. These parameters, these options are going to remain, most of the time they are going to remain same. So this is what we have seen: split plot, swarm plot. There are different arguments which we have used. Then we talked about matrix plots. In case of matrix plots, we have seen all these things. We loaded this particular data set, right? Heat map we have seen, .cor correlation. Pivot table we have seen. Always remember, pivot table is even if you go with Microsoft Excel, you will find out that there is an option called as pivot table. In Microsoft Excel, if you go to insert option, inside insert option, you will see pivot table. Basically, pivot table is something like which summarizes your data, right? This is how you can remember pivot table. So yes, we have talked about pivot table, and then we have seen this particular thing, bitmap, which is again very important, right? And then the different arguments which are present in the heat map. Cluster map also we have seen, which uses certain type of a clustering, right? So yes, that's what we have seen, and then finally we started with the grids. Now for grids, if you remember, we talked about a data set which is iris data set, right? The data set which was related to flowers, different species of flowers, if you remember, right? So That's what we have done. So I told you that there are some data sets which are already present in case of Cbon. You always use cbon.load underscore dataset and the name of the dataset. So here, what we have in this iris dataset is, so if you see these things, uh, these things we have already plotted actually in the last session, or otherwise let me check if whether we have done with that particular part or not. Just a minute. Okay, till matrix plot we have done. See, in this one, I think this was the last point which we were talking about in the last session. Right? Now what I will do is I will start with these grids. Okay, so let me close this extra tabs. Now just to make the things clear, see distribution plot, categorical plots, and matrix plots. This is what we have seen. Today we are going to complete everything about Cbon, and then we will finally start with the first algorithm, that is linear regression. This is what we are going to discuss today. Okay, talking about grids. Okay, so as usual, what I will do is I will go with a new notebook and try to execute the things in front of you. So first of all, what we are going to require is we going to require to input all the necessary packages. So this thing, import cborn as SNS, import matplotlib.pfplot as PLT, and percentage matplotlib is inline. This is nothing but a magic line. So I'm going to run all the inputs as usual because we are going to need that. Now after this, once this is imported, see there is a star in, this star will be gone once this particular thing is run successfully. Okay. So what I will be doing is, I know that SNS is alive for Cbon, so I will be using SNS dot load underscore dataset. But still it is running. This first still itself is running. Okay. Now it has run completely. You can see one here. Now I can press tab button and it will auto complete. So SNS dot load underscore dataset. Now which dataset I want to load? So I want to load iris dataset, right? So I will name that particular dataset as iris. Same variable I will be making it. Iris equal to SNS.load underscore dataset iris, and then run. So if I want to show you the complete dataset, shift enter here. Now see, this is what the dataset is. So what do we have in that dataset? Sepal length, sepal width, petal length, and petal width, and the species. So there are three types of species. Setosa is one of the species of the flowers. Virginica is one of them, and versicolor is other. So there are three species actually. And how many number of records are there? So 150 rows are there and 5 columns are there. So 150 observations or rows and 5 columns. 1, 2, 3, 4, 5. Okay, so this is the data set which we have. Now for this data set, or with the help of this data set, we going to learn about the remaining part in case of Cbon package. So the first thing which we are talking about is grids. So why do we make use of a grid actually? So whenever we want to have multiple graphs at the same place, we can make use of grids. Okay, like rows or columns in the form of matrix, I can say that's nothing but a grid. So see, this is the command cborn dot pair grid. So pair grid is going to do what? Pair grid is going to see which are the numerical data which are present in your data set. For example, if you see what is the numerical data in our case, sepal length, sepal width, petal length, and petal width. These are the four variables for which the values are numerical. Right? For fifth column, that is species, the values are not numerical, right? They are string. So what SNS.pair grid is going to do is it is going to identify the numerical data, and for that numerical data only it is going to create the grid. I need to say cborn dot, this is the command pair grid. Here inside this I am going to pass name of the data set. Now if I go and if I shift enter here, that is running, you will be able to see something like that. Now what is this? These are, so in my case it is not showing you those square boxes. Okay, maybe I will have to check the settings, but you can see that which columns it has considered. So it has considered only those columns from my iris data set where the data is numerical. Sepal length, sepal width, petal length, and petal width. The species column it has not considered because it is not numerical. So by default, this pair grid is going to do what? It is going to form those many number of rows and columns as per the data set. But for which columns? For which columns from the original data set? So only for those columns or the variables for which the data type is numerical. Okay. Just try to remember that particular. Now, so we have plotted this particular thing. Now on this one we are going to plot different plots. So SNS.pair grid. Now suppose I want to plot scatter plot. So yes, I can do that. So for that, what we need to do is we need to create the object of this type. So as it is created here, G is equal to SNS dot pair grid, right? So suppose let me run. Now same thing it is going to show you. Now, I want to make use of that pair grid. So what you can do is G dot, because now what is this G? G is the object of the type pair grid. So G dot, suppose let me go with this plot. So G dot plot, and here inside this I will be making use of matplotlib. How we have imported matplotlib? So you can see that matplotlib package we have imported as PLT. PLT is a alias, the short name for matplotlib I can say. So here G dot plot PLT dot, that is matplotlib dot scatter. Okay, and let's run this. Okay, what is the, let me check. Okay, it should not be G dot plot, it should be G dot map. G dot map. Now, PLT dot scatter. Scatter plot is one of the examples. Like this, we can plot other plots also. So for example, if I go and if I try to show you, see something like this, we will be able to see here. Now, what is this? It is showing us the relationship of every numerical column opposite every other numerical column. For example, I want to know what is the relationship between. So I think we have discussed this particular part also last time in one of the plots, that is pair grid. If you remember, there was something called as pair grid, which was showing us the same thing. So see, I want to see the relationship between sepal length and I want to see the relationship between petal width and sepal length, or petal width and petal length. So you can see that this is somewhat linear. Obviously, this column and this column they are the same. So same column opposite same column, obviously you will be getting a straight line here, right? So this is a scatter plot with the which we have plotted, which is showing the relationship between all the numerical data sets or the numerical columns, I can say. Okay. So I think something similar to that we already talked about. Now see what is the benefit of using this pair. So here you can plot whatever you need. As you can see in this particular case, what am I getting? Everywhere it is scattered. See, you can check that the diagonal, if you consider this whole thing as a matrix, this is the diagonal of a matrix. Now this is the upper part of the matrix, this is the lower part of the matrix. But on the both sides you will see that it is scatter plot. Here also it is scatter plot and here also it is scatter plot. What if I want to make use of different plots? So yes, that's what you can do with the help of SNS dot pair grid here. So the command to make use of different plots will be like this. See, this one we have seen creating an object of the type pair grid. Now on the diagonal I want histogram. So what I will do is g dot map underscore diagonal pl dot histogram. On upper side, what I want is on the upper side of the diagonal I want scatter plot, and on the lower side of the diagonal I want KD plot. KD, if you remember, kernel density estimation, right? So this whole thing now I can run and I will be able to see the plots according to the requirement. See, the histogram, scatter, and KD plot we already talked about. Now see, same thing, but you can check it on the upper side of the this particular diagonal. You can see scatter plot because we have written PLV.scatter on the upper side of the diagonal, and on the lower side it is KD, kernel density estimation. That is this particular part on the lower side of the diagonal, right? So that's how you can make use of this pair grid to plot the plots according to your requirement, right? You have this file, I have already told you, even you can also try it out. Okay. Now, or otherwise we have an option called as pair plot. So pair plot is one of the easiest command and it is actually very useful. So what you have to do is just go and type sns.pair plot and give the name of the data set. So it's also going to show the scatter plot by default. See, for upper and lower side of the diagonal, you will be able to see scatter plot. Again, talking about the interpretation of this particular diagram or the plot, you can see most of them they are linear, right? Or otherwise you can say that if the petal length increase, petal width also increase. So obviously number of interpretations can be made from all these graphs. But anyway, in the coming examples when we will be discussing about linear regression, logistic regression, decision tree, at that time this is going to be repeated again and again, because in every algorithm will be solving some problem statements. In that case we need to understand the data. So to understand the data, this is what we are going to require. Okay, so yes, remember this particular command. This is something very useful. But remember, by default, it is going to consider only those columns, only those features for which the data type is numeric. Okay, That's what you need to remember. For what we can say for string type of a data, what you can do is you can make use of few parameters, which we already talked about in the previous cases, right? So now see, few parameter you can make use of. So in our case, species is nothing but what? It's a string data, right? So yes, for that I can go and I can make use of. So suppose I want to understand, I want to analyze the data set, IDs data set with the help of all the columns. So I want to make use of this species column. We have to check the spelling also. Let me check. Okay, just ES it is. So otherwise it would have given me error. Right. So what I will do is Q is equal to species. Let's try to run this. Now I will be able to understand the data set in more detail. Because now what has happened here? Here you can say there are three species, right? So which are those species? Now pair plot has taken those species by default. You can check this particular thing, legend, right? The blue one is representing Setosa species of the flower. Orange one is representing versicolor species of the flower, and green one is representing Virginica. Right now, you can compare this, compare every column, every feature, with every other feature, and here you can see that the what we can say more idea you are going to get with the help of this particular plot as compared to the previous one. So for example, if you can see, suppose I want to compare maybe suppose petal length, petal width and petal length. We can check that this blue color is having lowest petal width and lowest petal length. Similarly, more than that is this orange color, and then more than that is the green color. So if you see this particular thing, what is that orange? Orange color is versicolor, versicolor species. It is a flower of the species versicolor. Now the flower Virginica green is having highest petal width and highest petal length as compared to others. Right? Like this, number of things can be interpreted with the help of this type of plot. So remember that pair width is something important. And obviously, as usual, you can make use of this palette option. I hope you remember this palette option we already talked about in the previous plots also. Right? So let me check this set one was somewhat here. Now see, this is set one. Again, same thing. It is just going to change the colors. That is it. Okay. So now that was SNS dot pair plot. Remember this particular thing. This is going to be very useful. We are going to meet that. Okay. Now let's try to talk about the next thing, that is facet grid. Now what is this facet grid? Facet grid is again not compulsory. If you want to make use of that, you can, but there are direct graphs also. Facet grid is going to give something like this. See, it is going to create some boxes, and which will help you to understand the data in more detail. Okay, so what we will do is, first of all, I will go and I will try to import this particular data set. I will try to load this data set. Tips, which you people are already aware about. In tips, what do we have? Total bill, tip, sex, that is male, female, smoker, yes or no, date, that is Thursday, I think Monday, Thursday, Saturday or Sunday, time, lunch or dinner, and size. Okay, so as usual, what I will do is this particular data set. For this particular data set, we will try to understand what is that specific rate. Okay, this is my tips data set. You know that how many number of rows are there in Page. So 244 number of rows in 7 columns are there. So tips dot head command is just going to give you first 5 rows. So just to have a look at the number of columns and the name of the columns, and I will be writing it down like this so that it will show me first 5 records by default. Okay. So this is my tips data set. Now what I want to do is I want to understand what is that facet grid. Okay, what is the concept of facet grid? How actually it is going to help us? So let's take this particular example. SMS seaborn dot facet grid. Okay. Now tips is what? Tips is the data set. Okay. Now there is a argument called as column and row. So what facet grid is going to do is it is going to talk about your data. It is going to represent your data graphically by taking time column as a column and smoker column as a row. Let me show it to you. See, here again we are creating an object. G is equal to SNS dot facet grid. This is the name of my data set. See, if you do not remember anything, go here, press shift tab, and you will be getting each and everything. Okay, what is the meaning of each and every argument? What are the arguments in this particular method is going to accept? Everything you will be getting with example. Right? You need to do what? Go here and press shift tab. I have repeated it number of times. Now see, what am I doing is g is equal to sns.facetGrid. So I am creating an object of the type facetGrid. What's going to happen is it is going to represent my data by considering something like this. So column it is saying time. Now in time, what are the values I have? So time can be lunch or time can be dinner. So it's going to represent the data in this manner: lunch, dinner. Smoker. So smoker, what are the possible values of smoker? Yes or no. Now it is going to do what? Yes or no. So lunch, smoker. So how many total bills they are generated? Dinner, smoker, how many total bills they are generated? Similarly, lunch, non-smoker, and dinner, non-smoker. So I mean to say, it is going to help me to represent my data in easiest manner possible. Let me show you. First of all, what's going to happen is it is just going to create this kind of boxes according to what column we have given and what row we have given. So in our case, column is what? Time. Remember, in time, what are the values possible? Lunch or dinner. In smoker, yes or no. Now, just to make the sense from for this particular thing, see what you can do is, as we have created an object already, now what am I going to do is I am going to plot a histogram. Right? I am going to plot a histogram, but for which column? Total bill. I hope you remember, right? Histogram and this total bill is one of the columns in text data set, right? So same thing, same command I am going to make use of, that is this G object we have already created. So G.map method we are going to make use of here. Okay. So which plot I want to plot? So in case of scatter, in case of matplotlib, that is PLT, I want to plot histogram. So PLT.hist, comma. Now here what I want is I want column as time and row as smoker. Now with respect to this, I want to check this particular value present in this particular column, total bill. Let me just go here and run it. Okay. Now you can check it. Now you can easily interpret this particular graph. See. So what it has done, try to understand what has happened because of this column and row. So you can easily check that here we have plotted the histogram, but this time it is giving us a lot of information or more information, in detail information. See, smoker, yes, and lunch. So, and what is this talking about? This is talking about total bill. We are talking about total bill, right? So, what is the pattern of the total bill generated by the people at the time of lunch? Or what is the pattern of the total bill generated by smokers at the time of lunch? So, see, you can check it. What is the pattern of smokers at the time of dinner? You can check this. So you can one can notice that smokers prefer dinner time as compared to lunch. Okay, that is one thing. Similarly, you can go and you can make a lot of other interpretations. For example, non-smoker and lunch. So this is the pattern they follow. What you can compare is, see, non-smoker generate more bills as compared to smokers. Non-smokers generate more bills as compared to smokers at the time of lunch, right? And what is the behavior of non-smokers at the time of dinner? So they also prefer dinner time. Maybe they might be coming in with their family, right? So they also prefer dinner time. But yeah, as compared to smokers, their what we can say, total bill, the range of the total bill is somewhat lower. But yeah, not that much. But they also prefer dinner time. So it means we can notice that whether it's a smoker or non-smoker, both of them they prefer dinner time as compared to lunch time. So here, like this, what you can do is, instead of this total bill, same thing you can analyze for tips also. Who gives more tip, whether it's a smoker or non-smoker? At what time they prefer giving more tips, whether it's a dinner time or lunch time? For example, let me check. Instead of this total bill, there's a tip column in our case, right? Tip column. So let's try to analyze this tip also. Let me run it. Now you can check it. Who gives more tips? So again, more tips are given at the time of dinner as compared to lunch. You can notice that, right? You can notice. And at the time of lunch, it's non-smoker people who give more tips as compared to smoker people. At the time of lunch, I'm talking about, right? Definitely, you can have more. You can have all these details in more detail. Okay, we can see that even we can make use of few parameters also. We haven't used it yet, but yes, we can make use of that. So this is nothing but what? This is nothing but the analysis. Now see, next example it is showing you. SNS dot face grid tips column equal to time, row equal to smoker, and hue parameter we are making use of, right? Now what's happening here? Let me show you. If you go and if you try to make use of hue parameter in our case directly, hue is equal to, so male or female, suppose I want to say. Let's run it. Now you can see, right? If I want to understand who gives more tip, whether it's a male or a female. But here what is the problem? We are not able to understand which color represents male and which color represents female. So for that we are going to require something like legend, right? Which is going to represent that, okay, this is male and something like this is female. So which color represents male and which color represents female? We are not sure about that. So because we haven't added a legend, dot legend method here. So I need to go and I need to add a dot legend. Check it. Okay. So let's see. Okay, so it is giving me error. Let me check the syntax. Okay, it is dot add underscore legend. Let me see. Dot add underscore legend. Let's see. Now see, you can check it. The blue is the male and orange is the female. That means it is male who give more tips as compared to female, and that's the general scenario, right? That's what generally we see. Okay, because maybe many times it might be the thing that it is male who is paying the bill if they are going as a family, for example. But here in case of you can check, in case of lunchtime, in case of lunchtime, it is female who is giving more tips as compared to male. Right? For some of the data sets, you can check it here. Right? For some of the data point, I can see here in this case. Otherwise, at the time of dinner, it is a male only who is giving more tips as compared to female. Okay, so how we are able to get this with the help of hue parameters? Always remember, hue parameters always make use of for character data or string data. Okay. Now here, instead of histogram, I could have used scatter plot also. There are other plots also. In case of macroclip, we have already seen that, right? And here, instead of talking about only one column, you can make use of two, tip as well as uh, total name, or maybe any other numerical column, whatever we want, right? The same thing, if I want to show it here, instead of this histogram, suppose I want to make use of scatter, but for scatter, let's see, scatter, clearly not scatter. If I go, it is giving me error because for scatter, what you are going to require is you are going to require x-axis and y-axis. And that's what I need to give. So if is done, suppose I need to give one more column here, total underscore bill, and let's run it. Now see, because for scatter we are going to require both x and y axis. Okay. So tip and total bill. Now you can check that what it is representing. So you can read all these things. Smoker at the time of lunch, total bill. Smoke non-smoker at the time of lunch, total bill. Right? And male and female. So you can check these blue ones are the representing male, blue markers are representing male, and orange markers are representing female. Similarly, smoker at the time of dinner. Okay, and here you can see as we have what this particular graph is showing you is it is showing you the relationship between total bill and the tip. Try to understand. So tip is on x-axis and total bill on y-axis. So this is the relationship between them. So for smokers at the time of lunch, this is the relationship between total bill and tip. Similarly, smokers at the time of dinner, this is the relationship between total bill and tip. So in all the cases, you can see that it is somewhat linear, and it's obvious that as the total bill increases, tip is also going to increase. So you can check it. See on the x-axis, what do we have here? It is tip only. Tip and tip. Total bill. So y-axis represents the total bill, x-axis represents the tip, and as per our requirement, it is giving us the analysis, or it is giving us the idea through these visualizations. Okay. And it's a simple question. If someone is asking you why to do all these things, why it is necessary. I also get this kind of question many times. Why to do visualizations? Why it is necessary? In simple words, see, obviously there are a lot of advantages of visualization, but in simple words, I can say that if you talk about humans, as a human, you might be knowing, right? It's always easy for us to understand through pictures as compared to the numbers or the text. That's why. That is one of the main reasons actually why visualization is needed. And this Seaborn is one of the Seaborn and Matplotlib are one of the are some of the packages which help you to do that. Okay. So joint grid is what? Joint grid is going to help you to plot two plots at one time. For example, see, what am I creating here is SNS.joint grid. I am plotting a graph between total bill and tip from the data tips. Which graph? Which plot? Regression plot and distribution plot. So how to plot two plots at the same time? There, this joint grid is going to help. First of all, create the object, and with the help of that object, plot the graphs or visualizations, whatever you need. So here we are getting regression plot as the main plot and distribution plot as another plot. Let me show you. See, and do not worry about what is this line. Today we are going to talk about linear regression algorithm. In that case, I will be talking about this particular line. Actually, it is called as a regression line. Okay, so in our first algorithm, it will be clear how to draw this. I will be talking about each and everything in detail about this particular line, regression line. But here, try to understand joint grid, what it has given us, distribution plot it has given us, this one, and the regression plot. So this one is the regression plot, and these are the distribution plot. And I already explained it. See, actually, this is nothing but scatter plot. But this line, because of this line, it is called as regression plot. Now, how to draw this line? What is the method to draw that particular line? That we will see in the next concept, which we are going to talk about in regression algorithm. But here, remember, regression plot looks like this, right? And I think in next topic, there is a separate active and for regression plot. Okay. So I think yes, this is all about the fourth point from Seaborn, that is grids. Just close it. Let's move to the next point, that is the regression plot. See, this fifth point you can see regression plot. So this is the IPY file for regression plot. Regression plot is the plot which we have just now talked about. Right? So you can read here. Seaborn has many built-in capabilities for regression plot. Okay, but I will be talking about this in detail once we start with the linear regression algorithm. So the name of the method is LM plot, linear model plot, which allows you to display linear models. Okay, so let's see. This particular data set is already loaded in our case. Now let's directly move to this particular count. SNS.lm plot. LM means linear model. So I am trying to plot a graph between total bill and tip from the data tips. So straightforward command I can say. Right? I will be getting a regression plot. See, this is called a regression plot. It is actually a scatter plot only. But the thing is that we are getting this particular straight line. Actually, that straight line is called as line of best fit. But we haven't yet discussed about line of best fit. We'll be talking about that thing. Okay. So basically, we'll be making use of equation of a straight line. You might be knowing about that, right? In the case of linear relation. Y is equal to mx plus c is the equation of a straight line. So in case of linear regression, that's what I said. That we will be talking about the logic behind how to draw this particular line and what is the criteria on which to follow for that. Okay, so this is the command to draw linear model plot. That is called a regression plot. And yes, there are parameters like hue parameters definitely you can make use of. So let me show you a simple example here. Suppose I want to know same data but in more detail. So let me go with the column called as time, dinner or lunch. So you can see that the orange is dinner and the blue one is showing the lunch. So you will be getting two separate lines because one is for dinner time and another one is for lunch time. These are called a line of distance. Okay. Now let's see what else. Palettes we can see working with the markers. This is just a fancy thing. In case of SNS plot, SNS.lm plot itself, we have a lot of options. This one we have seen palette, you already are aware about markers. Now this circle marker, whether you want to make use of, this V-shaped marker, you can make use of. And scatter keywords. S is nothing but what? It is representing size of the marker. Once you run it, you will understand. This is just a fancy thing. Okay. Check it. Now what's going to happen is, obviously you are going to get the regression plot only, but see now, for male it's a circle and for female it's a V shape, right? Something like this. So I can go and I can change all those things. Suppose let me check whether this one works or not. Let me see. Okay, this is not working. Let me just small s. So there are other options also which are given. Yeah, now see it is working. If I go and S stands for square. So now for female it is square. Right? If you want to increase the size of this one, let me make use of instead of 100, suppose let me make use of 500 and let's run it. Now check the size of those markers is increased. Right? But obviously it should be as low as possible. Otherwise it will be overlap. Now see the size of the markers. It is decreased. So S actually stands for size. So as I told you, this is just a fancy thing. Just try to understand LM plot is the command to draw regression plot. And again, we can make use of grid here also in case of LM plot. So let me directly go and let me directly show you this particular thing. SNS.lm plot. On x-axis total bill, on y-axis data is tips. Column is day and hue is male female and palette is good one. So you can see that it is going to give the visualization according to day. So what are the values in column? COL column, this particular column, or day column, it is Thursday, Friday, Saturday and Sunday. So according to those days, it is going to give me regression plots for total bill and tip. For total bill and tip. On x-axis total bill, on y-axis tip. So this is the plot. Okay. So the important thing is, see, you can make use of this one. COL, which we have already talked about. Aspect size and ratio, again this is a fancy thing you can make use of. There are two arguments which are added here, aspect and size. Let me show you in short. See, aspect size 0.6, size aspect ratio 0.6 and size is 8. If I go and if I run it, okay, it is giving me warning that the size parameter has been renamed to height. So instead of this size, I should make use of height. And then run it. Now it will not give me warning. Right? So you can check it. Height, now you can see the height, this height is increased. If I want to decrease this height, suppose I want to make it as 2, you will see the height decreased. Right? If I want to decrease it more, suppose let me make it as 2. Now the height of the graph is decreased. So yes, how you want to represent all these things, it all depends on your requirement. So you can check the height of the graph. All this visualization is actually decreased with the help of height equal to parameter. All the other things are same. SNS.lm plot, x-axis, y-axis, what is the dataset name, column, u parameter, palette, aspect, and height. Okay, so that is about regression plot. As I told you, we will be talking about regression plot in detail in case of linear regression. That is the first one. And the last point from Seaborn package is styling and color. Okay, style and color. So you can easily go through this style and color. You can check it. SNS.count plot. So remember this particular plot. SNS.count plot is going to do what? It is simply going to count the number of records in a particular column. So how many number of male are there? How many number of female are there? You can easily get that idea with the help of SNS.count plot. X-axis, right? X is equal to sex, that means male or female. So count plot simply gives you count. That means there are more male who visited the restaurant as compared to female. That simple idea you can get it from here. So I can see that there are, I think there are about maybe 155 male support, and there are maybe 90 female. Something like this is actually showing. So count plot simply gives you the count. Okay. Now, what is this SNS dot set underscore style is equal to white? So this is actually going to change the background. See, what's going to happen is I will be getting the same graph, but here in my case the background is already white. This one, instead of this white, let me make it as dark background. And let's try. Now see, what is the difference between this figure and this figure? Here the background is dark, here the background is white. So that you can check with the help of SNS.set_style. Okay, and there are other options also. And what else? Say ticks. Ticks is what? Because of this ticks, see, you can check it. Let me show you here. Now see, there is no box which is drawn for this particular diagram. Okay, see what I mean to say is, if I go and if I run this, now see there is a box here, right? Which box I am trying to talk about? I am talking about this particular box for this compound, this box, right? Which was not there earlier. You can check it. Which was not there earlier, right? In this graph there was no box, but now in this particular plot there is a box. So it is possible with the help of these sticks. Now this, in this case, if I want to remove this particular thing or this one or everything, I can remove that. That's also possible. So it is also one of the fancy things which you can do. See, so we make use of something called as spine removal or D-spine function. Let me run this particular thing, and here by default it is going to remove some spines. Let me run it. Now here what am I getting is I am not getting a complete box. So it has just removed the line from the top and the line from the right. What if I want to remove a particular line from a particular side? So you can check it. SNS.D spine left is equal to true. So from the left side it is going to remove the line. Which line it is going to remove? See, left is equal to true. That means this spine is going to be removed. Okay, try to understand that. Let me run it. See, D spine is the command. SNS.D spine left is equal to true. So it is going to remove that particular left spine. You can check. Now in my plot, that left spine is not there. Yes, you can see it's one of the times. Size and aspect ratio. So PLT.figure, matplotlib.figure, figure size 12,3. So this 12 is nothing but the width and this 3 is nothing but the height of the figure. Whatever the plot you want to plot, you can. Suppose, let me show you if I make the changes here. Let me run it. I will be getting a count plot, but you can check this. The width is the 12 and the height is 3. Suppose I want to check, I want to change the height. I want to make it as 8. And you will see that the height is also increased. Okay, or maybe I want to decrease the width, so I want to make it as suppose 4. You can see that the width, this particular width is decreasing, okay? Or otherwise let me change this one. Let me make it as 4. We will be getting something like this. So it's in our hand how we want to actually represent, okay, represent the plots. So this is nothing but aspect, style and style and color. How you can actually make the plot. And that is possible for every graph. You can check it. The SNS.lm plot, total build tip, size equal to 2, aspect equal to 4. You go and try to see, try to change the things. Okay, instead of this size, they are saying that you should make use of this particular argument height. Okay, and scale and context also. If I want to change font and all those things, that's also possible. So SNS.set_context poster. So there are different options available instead of this. Let me show you this particular thing first. See, I'm getting something like this. Suppose I want to increase the font. Yes, that's possible. Suppose let me make font underscore scale is equal to 5. Let's see this now. Now check, the font is increased. Right? But obviously it is not fitting here. So I should go and I should try to decrease the font. Let me make it 2. Now this is what I got. Right? And if you want to know which are the different options available here, go here, press shift tab, and you will be able to see some options. Or example, see, it can be a paper, it can be top, it can be top. This context, as they have given us poster context, so you can make use of these options. Paper, suppose, see, here it is poster. Instead of this poster, let me try to make use of paper, and let's see what is the change. So it's a plain paper kind of a thing. If you want kind of a poster, you can give you a better option. You can say now it's more bold, right? Or more darker as compared to the other. Obviously, if you want to change the size of this one, let me make it as 0.5 suppose. See, now see you can change the size is 0.5. It looks proper. Okay, so that's what the style and color is. And yeah, that's all about the last package. That is nothing but the C bond. And at the end, I hope you people will go through the exercise which is given to us and whatever I have shared till now, right? At the end, for each and every package, I have shared exercise and its solution. If you really want to understand the things, I will recommend that you go through the exercise, each and every exercise. See, solution is already given to you, so that will not be difficult on your part, right? Okay, so that's it about Seaborn package. Now, what we will do is, as per your syllabus, we will try to start with the second point, and that is nothing but linear regression. So let's try to start our discussion with this particular topic. As I told you that I will be talking about this hypothesis testing, inductive bias, bias and variance, then cross validation. All those points I'll be talking about here. Right? We'll be finding it out all those things in my notes, which I'll be sharing. Okay. Now, to start with that particular point, let me go and let me open the file itself first of all. Let me go to the location where that particular file for linear regression is kept. So you might be knowing, you might have used linear regression many times. You might have solved simple linear regressions, multiple linear regressions, right, many times. So yes, this concept is related to the linear regression or the mathematics which you might have studied earlier. Definitely that particular thing is going to help you a lot to understand all these things. See, now as we want to start with linear regression topic, let me just remind you why I will be discussing it, because linear regression is one of the basic algorithms when we talk about machine learning or data science. And specifically talking about this linear regression algorithm, this is used for what? This is used for prediction, right? Those people who are present for starting the sessions, right? Maybe first or second session. If you remember, I told you what is supervised learning, what is unsupervised learning, what is semi-supervised learning, and what is reinforcement learning. So in that case, I told you that linear regression is a algorithm or a machine learning technique which is used to solve the problems which come under supervised learning approach. That means here, wherever the data is labeled data, that means you have column, some columns as input and one column as output. In that case, you can make use of linear regression algorithm to solve the problems. And basically, it is used to solve which types of problems? The problems where you need to predict something. See, I'll be showing you, as I told you, I'll be showing you how to create an application with the help of linear regression, in which you will be predicting something. For example, I want to create a model where that model is helping me to predict the maybe share market price. So that problem you can solve with the help of linear regression. Suppose I want to create a model which is predicting the marks a student is going to score in the next exam, depending on his previous scores. So linear regression can come into picture, right? Or maybe suppose I want to predict petrol prices, what it is going to be, right, in the next month. So I can make use of previous data, and to train my model, I can make use of linear regression. But obviously, what is necessary here? You should have proper data, right? Unless and until you do not have a data set, we cannot do anything. Because once we have data, we will clean that data, we will do all the pre-processing with that data with the help of the packages which we have seen till now, and then we apply linear regression algorithm on that data, and then we try to come up with a model which is going to help us to predict, right? Because through this model we will be passing real-time data, and that model is going to give us the output. That is, maybe for example, what is the price, petrol price in the next month, something like that. So whatever you want to predict. Okay. So basically, my point is that linear regression is actually used to solve the problems where you need to predict something. Okay. So before going and discussing all these things in this notes, what I will be doing is I will be talking about the concept of linear regression in a very simple example. Okay. So, and I hope you remember. Okay, supervised learning, unsupervised learning, all those things you are already aware about, because there is not only linear regression, there are other algorithms also which can help us do the same thing which linear regression can. And at the time of when I started with this particular subject, I already told you in the basic definitions and types of learning, I already talked about those algorithms. I already mentioned those algorithms, if you remember. Okay? So always remember that there is not only linear regression. Linear regression is a very basic algorithm. Linear regression is a algorithm which is good to start with if you really want to understand machine learning or data science. Okay, so what I will be doing is now I'll go and I will try to explain the concept of linear regression first, and then we will go and we will try to refer this particular these notes where I have shown you the implementation and some other aspects, right? The mathematics behind the linear regression algorithm. All the things are actually incorporated at one place in the Jupyter notebook. So this is what I will be sharing with you people. These are the notes for in which you will be getting each and everything about linear regression and some more terms which we always need for other algorithms also. I hope you might be knowing about maxima, minima, what is derivative, what is the use of derivative, all those things. I hope about. That's what we are going to need to understand the concepts. Okay. So let me start with the concept of linear regression first. Let me explain you with a very simple numerical I can say, and then we will go and we will try to implement it in Python. Right? As we are discussing everything related to Python itself, so we will be making it a Python language only to implement linear regression algorithm. Right. So I hope you people are able to see this particular black screen. Right? So let's start with the concept of linear regression. Now, what am I going to need here is I am going to need a data set. Right. So to understand linear regression, let's consider a simple data set. For example, we have a data set which is talking about what you can say the ratings. The rating is given by different people. So for example, there are 6 to 7 people who have given the ratings for Bahubali movie. Okay. So ratings given by a person for Bahubali Part 1 and rating is given by same person for the movie Bahubali Part 2. Something like this here, let's suppose. So obviously, in real time, what's going to happen is that data should be as what we can say, number of records should be as high as possible, right? But we cannot go with a lot of records here because we have limitations. We just want to understand the concept. That's why what I'll be doing is I'll be talking about very less data, less number of records or rows I can say. Okay. Let's suppose first person has given the rating to Bahubali Part 1 as 4 out of 5. Second person has given the rating as 2 for Bahubali Part 1. Okay, third person has given suppose 3 as the rating. Fourth person has given 5 out of 5 for Part 1 I am putting. Then the next one has given 1 and the next one has given 3. So these are the ratings of 6 people for the movie Bahubali Part 1. Similarly, we will see what are the ratings of those people for Bahubali Part 2. Let's suppose first person has given the rating for Bahubali Part 2 as 3. Who has given the rating as 4 for Bahubali Part 2. And similarly, second person has given 4 for second part. Suppose 2. This person also has given suppose 5 out of 5 for second part. 3 and suppose 1. Right? So let's suppose this is what our data is. Okay. Now, what's next is we want to create such a model. See how many number of people there are. So you can check 1, 2, 3, 4, 5, 6. So 6 people are there who have given their reviews. So what we want to do here is we want to create such a model with the help of linear regression in such a way that, for example, if next person comes and he gives the rating as 3.5 for Bahubali Part 1, so we want to create such a model which is going to help us to predict what will be the rating of this person for Bahubali Part 2. Okay, this is what we want to find out. Okay, so let's suppose this Bahubali Part 1, I will name it as X column and this I will name it as Y column. Just to save the space. Okay. Now, how are we going to proceed with this? I hope everyone understood what we want to do. Okay, so we want to create such a model which is going to help us to predict what will be the rating of this person for probability part. Okay. For that, what we'll be doing is basically linear regression makes use of a straight line. And you know the equation of a straight line is what? Y is equal to mx plus c. Now, I think you people are already aware about it. What is that? What is that m? And what is that c? What is this m? M and c. What is m? Yeah.
Slope.
M is what? Slope.
Slope.
And c is what?
Y-intercept.
Y-intercept.
Y-intercept. M is the slope and C is the y-intercept. Can anyone tell me what do you understand the slope? Or how to calculate it? Maybe you might have come across this kind of a question related to some subject. How to calculate the slope? Any idea?
Using angle tan theta.
Tan theta you are saying. Okay.
Yeah.
So basically, if you remember, what we make use of is, okay, we will see what is how we are going to calculate this slope. Tan theta, okay, you can say that. Maybe you might use that in some example. So m is the slope and c is the y-intercept. So linear regression makes use of this particular thing. Now you will find out in many books. We can represent it like this. Y is equal to suppose beta 0 plus beta 1. I am just changing the variables or the coefficients. Okay. Again, same thing. Beta 1 is the slope and beta 0 is the y-intercept. Or both of them they are coefficients. Or in some books you will find it out like this. Y is equal to b0 plus b1x. Again the same. Now we can find out the value of y. That is output. Right? We can solve this equation for y if we are aware about value of b0 and value of b1. So with the help of this equation of a straight line, we can find out. Now, suppose let me consider this particular equation. Let me consider y is equal to b0 plus b1x. Now you might be knowing how to calculate this b1. So the equation for this one is going to be something like this. b1 is equal to summation of x minus x bar into y minus y bar divided by summation of x minus x bar whole square. Now, what is this x bar and y bar? First of all, let me tell you that. Okay, and then we will understand this particular equation. So, x bar and y bar are nothing but the average values of x and y. What is x? What is this x? X is nothing but our input column. And what is y? Y is nothing but our output column. Remember, see, if you remember in our first or second session only, I told you input column is going to be more than one. If it is going to be more than one, we can say that it is multiple linear regression. If it is only one input column, it is simple linear regression. But in real time, what going to happen is you are going to deliver the data in which you will be having multiple input columns. So maybe more than 30, 40. Here I am taking a very simple example where we have only one input column. So we call it as input column or independent column. Okay. Another name is explanatory variable. This is called an explanatory variable or a feature. This is what output. This is also called as target variable or label or explained variable. These are different terminologies which we make. Okay. Now, what is this x bar and y bar? I was talking about x bar is nothing but the average of x. Can you tell me what is the average of x and what is the average value of y? That is value of x bar and y bar. You know, right? How to calculate the average. So just let me know what are the average values of x and y. So that
3.
x bar is 3, y bar is what?
Okay. 3.
Yeah, okay.
Three.
Again, it is 2. So we have got x bar and y bar value. So in this equation of b1 is equal to summation x minus x bar into y minus y bar divided by summation x minus x bar whole square. So we have x bar and y bar value. Now what is this x and y value? X and y value are the original value. Okay, that means we can calculate this b1 value given all these things. So according to this particular equation only, we will go step by step actually. I will calculate x minus x bar value. Okay, calculate all these things. What else we are going to require is y minus y bar also we are going to require. This is another thing we are going to require. What else we are going to? So I am just writing down whatever is required according to that particular equation. The next thing which I am going to require is x minus x bar whole square. This is what we are going to require. And the last thing we are going to require is multiplication of this one and this one. That is x minus x bar into y minus y. So I have just written whatever is required according to the equation of B1. Okay. Sorry for this table. So, now x minus x bar. So what should I write down here? X bar value is 3. So 4 minus 3 is what? 1. So I should write down 1. Similarly, this 2 minus x bar is minus 1. Let me know if I am wrong. Okay. 3 minus 3 is 0. 5 minus 3 is 2. 1 minus 3 is minus 1. 3 minus 3 is 0. Similarly, y minus y bar. This is y. So y bar is also 3. 3 minus 3 is what? 0. 4 minus 3 is what? 1. 2 minus 3 is minus 1. 5 minus 3 is 2. 3 minus 3 is 0. 1 minus 3 is minus 1. I hope I am right. Right? What else? X minus x bar whole square. That means square of this particular thing. So 1 square 1, minus 1 square 1, 0 square 0, 2 square 4, minus 2 square 4, and 0 square 0. What we require is summation of x minus x bar. That's what I will do is I will find out the summation of this. So 4 plus 4, 8, 8 plus 2, 10. So I got value as 10. So denominator I got as 10. X minus x bar into y minus y bar. That is multiply these two things. So what I am going to get is 1 into 0 is 0, minus 1 into 1 is 1. This is 0, this is 4, this is 4. Okay. This is 0 and this is 0. So what will be summation? We are going to require summation also. Summation for this one. So summation of this one is what? 4 plus minus 1 is 3. That means b1 value is what? In numerator I got 3 and in denominator I got 10. So this is nothing but 0.3. So I got the value of b1. Now once we got the value of b1, we can easily calculate the value of b0. So how to calculate the value of b0? See, now our equation is what? Y is equal to b0 plus b1x. Now to calculate the value of this b0 now, instead of this y and x, just consider it as y bar and x bar. Okay. So y bar value is 3, b0 value we have to calculate. b1 is nothing but 0.3 and x bar is 3. So can you tell me what is the value of b0 now? Just simple calculations to it. So what we will get here? b0 is equal to what is it? 3 minus 0.3.
2.1 something.
2.1, just consider as 1. So yes, I got the value of b1 as well as b0. Now my equation is going to be y is equal to b0 value is what? 2.1 plus b1 value is what? 0.3. So y is equal to 2.1 plus 0.3x. This is the equation which I got. Okay. Now, what was our problem statement? We wanted to find out what will be the rating given by this person for Bahubali part. Instead of this question mark, we want to write an answer. Right. So, what we can do is, let me just go and let me try to suppose. Okay, what I will do is, I will try to draw x-axis and y-axis here. Let's suppose something like this. Okay. So x-axis is nothing but what? X-axis is nothing but these values. Rating for Bahubali part 1. And y-axis is suppose rating for Bahubali part 2. Now it is of on the range of 1 to 5. Right. So it is 0 suppose, this is 1, this is 2, 3, 4 and 5. Similarly 1, 2, 3, 4 and 5. Something like this we have. Okay. Now let me plot all these points. X-axis 4 and y-axis 3. So 4, 3. X4, Y3. So X4 is here and Y3 is here. So somewhere here that point is going to lie. First point. Similarly, second point is what? 2 and 4. So 2, x-axis 2 and y-axis 4 somewhere here. Similarly, 3, 2, x3, y2 somewhere here. 5, 5 is somewhere here. And 1, 3, x-axis 1, y-axis 3 somewhere here. And similarly, 3, 1. That is this one, 3, 1, x-axis 3, y-axis 1 somewhere here. So this is my given data set, right? Now we want to draw a line. So we have an equation. This is y equal to mx plus c or y equal to b0 plus b1 x is nothing but what? It's an equation of a straight line. So we want to come up with a straight line here which is going to pass through all these data points. Obviously, these data points are not sufficient to train any model. This fixed number of records is nothing, right? But we will try to draw a line which is going to pass through this particular data set. So how to draw that line? You know that to draw a line, we generally require at least 2 points, right, to draw a line. So x bar and y bar, what is this value? This is 3, 3. So what I will do is 3, 3 I will try to represent. This is x bar and y bar somewhere here. Okay, so this is nothing but what? 3, 3. X bar and y bar. And what is the next point we have? Y-intercept. What is the value of y-intercept? 2.1. So 2.1 is nothing but somewhere here. So I got 2 points, this point and this point I got. Now I can draw a line which is going to pass through these 2 points. And that line is going to be my line of this. Whatever I am trying to show you, this is a theoretical concept I can see. This is nothing but a straight line. Now this line, we call it as line of best fit. Now what do you mean by that? Line of best fit. So if we remember in the previous topic, we talked about regression plot. In that regression plot also, we were able to see that Seaborn was trying to plot a straight line like this. And that straight line was nothing but a line of best fit or best fit line. Always remember, best fit line always passes through dense area. What do I mean to say dense area? Dense area means where there are a lot of data points, right? And the distance of all the points from the line of best fit, that is this distance. If you draw a perpendicular line from this line like this, so this distance, this distance, for each and every point, whatever point you talk about. So this distance should be as minimum as possible. Suppose I will name it as distance d. So the line of best fit will be drawn in such a way that this distance should be as minimum as possible. See, actually you don't have to worry about that, because in case of Python we have a direct method which is going to take care of all these things. Okay, now what is this distance actually? So this distance is actually, we call it as residual. Remember this particular term, residual. Now what do you mean by residual? Residual means error. So I mean to say, see, on this line, now you know the nature of straight line. The nature of straight line is like it's always going to be straight. That means if I go further and it is going to move how? It is going to move in this manner only. It is not going to go like this, right? It is going to be straight only. So this is the nature of straight line. Now with the help of this, if you ask me any question now, I can answer that. For example, in the question, they were asking that if a person gives rating as 3.5 for Bahubali part 1, what will be the rating for Bahubali part 2? Yes, I can answer that now. So I can just go here and draw a perpendicular line which is going to touch this particular line of best fit. And respective to the y-axis, I will be drawing a perpendicular line here. So my answer is going to be somewhere here. So maybe this might be 3.4 or 3.2, something like that. So this is the answer I got. Let's suppose this one 3.4. Right? So this is what is going to happen actually in case of linear regression. This is how it is going to happen. It's not like that only for 3.5. You ask for any point now, because we are sure about the nature of the straight line. It is going to be straight only. Right now, so what's going to happen is, see, what's going to happen is we will be having some data. From that data, some data will be making use of training data and some data will be making use of testing data. That means for some data, we will be aware about the output in advance. That's why it is called as supervised learning. At the time of discussing the concepts of supervised learning, unsupervised learning, I already told you what is the difference. So, see, what happens is, whatever the rate points, these are the actual values. And these points, these are the predicted values. So, let's suppose this is the actual value y and this is the predicted value y cap. The difference between y and y cap is nothing but what? Error or the residue. Try to understand that. So, why I told you that this distance should be as minimum as possible? The error, as it is the error means what? See, suppose we have a data which is given by client, and in that data we are already aware about the output also. What we will do in that case is we will make use of the original output, and for the respective input we will try to predict the things, and then what we will do is we will compare the original output and the output which is predicted by our model. See, whatever you are able to see, these points are representing what? These are the points which are representing the predicted output, and the red points are these are the points which are representing the original output, and this is the predicted output. The difference between the original output and the predicted output is nothing but error for the recipe. See, I'll be showing you what we actually do. Whenever I talk about training and testing, what does that mean? When you will actually go and when you will actually practically see how it is being done, you will be able to correlate these things in that case. Always try to remember. See, what's going to happen is, let me use a very simple example. How we are going to make use of linear regression at the time of implementation. Try to understand that. See, initially, we will be given some data set by the client. Let's suppose in that data set we have 500 number of records. See, whenever I say 500 number of records, I mean to say there will be some input features and there will be one output feature. Let's suppose we want to create a model which is going to predict the salary of an employee. Salary of an employee. So salary is going to be our output column, and all the other columns are going to be our input columns or the features or the explanatory variables. Okay. Now, what's going to happen is, out of those 500 rows or records or observations, 70%, let's again 70 is not hard and fast. Some of you might have, if some of you have come across training and testing kind of a thing, or machine learning concepts, if you have come across, maybe you might have read somewhere, or you might have listened someone, you might have heard them saying that we divide data like this: 70 training data and 30% testing data. But it's not hard and fast. It can be 80-20, 75-25, 60-40, whatever. Okay. So let's suppose we divided our data into 70 and 30%. This data, this data. So when I say that 70% of the 500 number of records are training data, that means 350 number of records are training data. Remaining 150 are testing data. Right? So, but in this 350 number of records, we have input columns as well as the output column. So from this, we will be creating the model by applying, suppose, linear regression. We will apply linear regression to this 350 number of records, and we will train the model and we will create the linear regression model, which is going to help us to predict the salary. But now, while testing the model, what we will do is, there are 150 number of records which are remaining. So this 150 number of records, from this 150 number of records, we are going to pass this input columns only as an input to this model. We are not going to pass the output. We are going to pass input column only as an input to this model which we have created with the help of training data. We are not passing output. Okay. Original output is this one, salary. That means for that input, for these input features, our model is going to predict the salary. So let me name it as, suppose, predicted salary, or I name it as y cap. So it is going to predict for remaining 150 number of records, our model is going to predict salary. But original value of salary we already have. What we will do is, for each and every record, we will find out y minus y cap, and that is going to be our error. This is how we find out things. Is it making sense or what? Do you have any doubt? I will be showing you all these things practically also. But is it making sense? You have any doubt? You want to add something? Yes, can you just let me know in it out here? So this concept is, I don't know whether you people might be aware about it already. Hope so. Let me know that also. Yes. Any doubt? Any question? Are you able to make sense whatever is going on here? Yes, anyone? Even you can unmute yourself. Okay, okay. Thank you, Ninja. Thank you, Yunus. So people are saying no doubt now. I can see. I will know. I will take it as like you people are getting. Okay. So y minus y cap is going to be our error. This is how we calculate the error. So our target is what? This error should be as minimal as possible. So basically, while implementing, what going to happen is there will not be only one line which is going to be drawn. There will be multiple lines. See, if this is your data set, something like this, if this is your data set, there will be a line which will be drawn like this, this, or this, or this. Out of all these lines, we need to find out. Actually, machine is going to find out the best fit line. How? What it is going to do is it is going to calculate the error for each and every observation, and then it is going to find out the average of those errors. So the line for which the average of the errors is minimum, that line is going to be the line of test. And how to find out the minimum of the errors? So there we are going to use the concept of derivatives. Right? We will be discussing about something called as gradient descent. Maybe you might be aware about that. Gradient descent, which helps us to find out the minimum. Okay, something like this we will be making use of in case of linear regression. So yes, now there are some points we need to take out from this particular discussion. What is residual? Residual is nothing but the error. Difference between the predicted value and the actual value. That is called as residual. Line of base fit. There are some points about line of base fit. Like line of base fit always passes through dense area. Dense area means where there are a lot of points, lot of data points. And line of base fit is a line for which the distance between actual data points and the predicted points is as minimum as possible. This should be as minimum as possible. This one, this one, this one. See, let's suppose the actual value of y is 5 and the predicted value of y is what? 4. So 5 minus 4, y minus I cap is 1. So here we got the error as positive. But many times it will happen that, suppose let's say the actual value of y is 3 here. Actual value of y is 3. Sorry, predicted value of y is 3 and the actual value of y is 1. So 1 minus 3 is what? Minus 2. So we will get negative errors also. So the next point which I am going to talk about is nothing but how to calculate the error. Okay, so I hope everyone is clear till this point. Let me just clear everything. See, what I mean to say is there is something which is called as standard error of estimate. Okay, so once our model is created, we try to calculate something called a standard error of estimate, and it goes like this. It is the formula is like this: summation of y minus y cap. Y is the original value, y cap is the predicted value. So summation of y minus y cap whole square divided by n minus 2. Where this n is what? This n is nothing but number of observations, number of records, number of rows in your data set. And talking about this particular equation, why are we taking the square of this? Why are we taking the square? Because see, just now I told you, if you have a data set like this, let's suppose this is your data set. These are the data points in your data set. Okay. Now, if I go and if I try to come up with line of base fit, suppose this is my line of base fit, it's passing through dense area. Now, what's going to happen is this distance, this one, should be as minimum as possible, right? For all the data points, it should be as minimum as possible. Now what's going to happen is, for some points this distance will be positive, that is for all these points which are above this line the distance will be positive, and for all the points which are below this line the distance will be negative. So y minus y cap is going to be positive sometimes, going to be negative sometimes. So just to nullify the effect of these negative values, we are taking the square of this particular difference. That's why this square. Okay. And one more point, this n, I told you n is nothing but number of records, number of observations in your data set. This n, if it is very high, obviously you can just ignore this 2 in that case. Okay, you can just ignore that 2 if it is very high. So ideally this what going to happen is, ideally the standard error of estimate should be less than 1. Okay, it should be less than 1. Ideally it should be 0 ideally. But yes, that's not going to happen in all the cases. Right? So we'll be discussing about some methods which are going to help us to improve the accuracy of the model and so on. One by one we'll talk about that. Okay, so this is about the basic idea behind linear regression. I hope till this point everyone has understood what linear regression is, at least the concept, what is line of best fit, what are the properties of line of best fit, what is the residual, what is the meaning of the residual, right? And how to calculate that particular thing. Now, moving forward, so let me continue my discussion with this particular IPY file. As I told you, these are the notes which I will be sharing with you people. Now here, see, if you go and if you try to check in your syllabus, let's check how many algorithms are given in your syllabus. You can see linear regression is there, decision tree is there. Then there is a logistic regression, support vector machine, okay, and KMS algorithm is there. So 1, 2, 3, 4, 5 algorithms are there. But if you go and if you try to check, there are about 14, 15 algorithms which are there for machine learning. Generally, I talk about 14, 15 algorithms, right? But we will go with syllabus itself. Okay? The point of telling you is that, see, whatever I will be sharing, you will find out that the format is same. Whether it's a linear regression decision tree, you will be able to see that in all the nodes, the first diagram which you are going to come across is this one. This is called as machine learning model development cycle. It's a machine learning model life cycle. What do you mean by this? See, when I will be discussing about all these algorithms, at the time of implementation, I will be showing you how to create the models. Okay. So in all the algorithms, the first thing which I have shown you is machine learning model development life cycle. Machine learning life cycle. How to develop the model. What are the general steps? Okay. So that's what I will be explaining you first. Once we will implement this, you will be able to make the sense. See, whatever you are able to see, this particular diagram, it's like a flowchart only, I can say. This is nothing but a typical life cycle diagram for machine learning model. Now let's try to understand this particular thing. I will be explaining you this particular thing one time, because for all the algorithms it is going to remain same. See, whenever we talk about model development or whenever we talk about implementation of algorithm, what's going to happen is, initially we are going to need the data, we need to pre-process that data, we need to do something called as EDA, right? We need to check missing values, we need to clean the data. So before applying any machine learning algorithm, we need to do all those things. And if you remember, initially also I told you, before applying any machine learning technique or any machine learning algorithm, your data, first thing is the data should be numeric. If your data is not numeric, you cannot apply machine learning algorithm. That is the first thing. Second thing is the distribution of the data, or your data should be in normal distribution form, or it should be normally distributed. This is another thing you have to make sure. Normal distribution. Normal distribution is we are discussing the data, right? Bell-shaped curve, symmetrical distribution, and standard normal distribution also we have talked about. So these two are very basic things which one needs to take care of before applying any machine learning algorithm. Right? So we will see where this is actually going to come into picture. This is one of the steps of machine learning lifecycle. Okay, so let's start with that. See, first of all, what are you going to need is data. So data selection. Let's suppose we got the data. Client has provided us the location from which we need to fetch the data. Maybe a certain location on the server, right? So client has given us the access to fetch the data from that particular location from the server. Once we got the data, let's suppose we have our data in a variable called as data. Once we have that data, if you remember in pandas and in NumPy and other packages, we have seen something like data.describe. Describe method we have seen, summary method we have seen. So data.describe is going to give us how many number of features are there, how many number of rows are there, what are the data types of each and every feature, right? So a story of what data is all about and the features present in the data. So data.describe command is going to give us a lot of information about it. Even the data types of each and every feature it is going to tell us about. So that is going to be the next step. That means we are just going to understand what data is all about and how it looks like and what is the data type of each and every column. Because I told you before applying any machine learning algorithm, you need to check whether your data is in numeric format or not. Okay. Once you have checked the summary of your data set, the next step is, see, whenever I say data is, client has given us the location from which we need to fetch the data. So data might be coming from some database. So if you people heard about the databases, like it can be coming from MySQL database, it can be coming from Oracle database. Even if you are not aware about it, do not worry. I am just trying to put the things in front of you. Oracle database, it might be coming from some lightweight database like SQL Library. Okay, it might be coming from some database like MongoDB, or it might be coming through CSV files, Excel files, text files, and so on. Or there are some frameworks like Hadoop, if you heard about. Hadoop is there, something like Kafka is there. So it all depends on the domain, it all depends on the company. Right. So these are the different sources of the data. And once, so what we need to do is we need to fetch, we need to import that particular data set. Client is going to provide every detail about it. And once it is fetched, you can go and you can describe the data. And once you have described the data, okay, you will get the idea about number of features. Then you go and you check for statistical and graphical analysis. Now, statistical analysis, it means we have already talked about NumPy, shape, reshape, right? All those things we talked about. So I meant to say you need to make use of something like NumPy package here, or maybe like Matplotlib or C1 kind of a thing you can make use of it. Panda. To fetch, you can make use of pandas package, right? So statistical analysis, it is going to show you with the help of all the methods which we have discussed in case of NumPy package, right? You will come to know how many number of records are there, what is the shape, how many number of rows are there, how many number of columns are there, and whether it's a 1D or 2D or what, right? You can go and you can have idea about missing values, if there are missing values or null values, right? If there are zero, if there are some columns in which all the values are zero, so all those things you can get with the help of these things, right? So a simple analysis is going to happen here. Once that is done, there is a need to do data transformation and derivation of new attributes. So data transformation. Now, what do you mean by this? It means, let's suppose there is a column in which you have all the zero values. So obviously it is of no use, right? So one should directly remove that particular column. That is, if you remember, right, delete. We have seen how to delete, how to remove any column, how to drop method we have seen in the pandas. Those who are present or those who tried the things which I have shared with you. Drop method you can make it up to drop unnecessary columns, right? Or many times it will happen that you might need to combine two columns and come up with one column. So that is nothing but derivation of new attributes if necessary. So all those kind of things can be done. Dropping of the columns, adding a new column, combining the columns and coming up with new column. So that is nothing but a part of data transformation. Okay. And once that is done, so here again you can make use of pandas package. Okay. Then there comes selection of machine learning algorithm based on the patterns observed in the EDA. So EDA actually stands for what? EDA stands for Exploratory Data Analysis. Now what happens in case of exploratory data analysis? So here you can make use of Seaborn and Matplotlib kind of thing. Right? Basically it is nothing but visualization. Most of the times you will make use of all those plots here, and you will try to observe what are the different patterns in the data. So the last thing which we have discussed in Seaborn, right? Different plots which were giving you a basic idea about different patterns in your data set. So if you remember in the last example for the data set like tips, right? So in that we were having the columns like total weight and tips and the gender of the person and the time and all those things, right? So we notice that most of the people prefer dinner time whenever they want to visit the restaurant. So we try to observe the pattern in the data. And so it was possible with the help of C1. So basically you can make use of C1, Matplotlib, Pandas kind of package here instead of EDA. And once that is done, so again, what are the other things which you can do with the help of all these packages? In all these steps, what you can do is you need to do cleaning. If there are some missing values, now what in the missing values we already seen that. Why to take care about missing values? Because if you go along with the missing values and if you try to create the model, you will be able to create the model. But in that case, that model is going to be overfitted, right? Overfitted. We have discussed about overfitted model many times. Overfitted model is the model in which it will give you good accuracy at the time of training, but it will give you very bad accuracy at the time of testing. That is real time. Okay. That means for seen data, it will give suppose 90% accuracy, but for unseen data, it will give suppose 70% accuracy. So that type of model is called an overfitted model. And missing values or outlier values or extreme values, right, are the reasons of getting overfitted model. So that's what we need to take care in all these steps. So we call it as pre-processing. And then there comes data standardization and normalization. Now, what is data standardization? For example, let's suppose we have the columns. Maybe suppose in our example, see, in our the example which we are going to implement, in that example, we are going to create a model where we are going to predict the chance of a student. This is going to be our output column. Chance of a student to get the admission for MS. Right? What is the chance of a student for getting the admission for getting the admission in MS? So this is our target column actually. Now this is our target. Now along with this target we have some input columns. So what was a GRE score? Right? GRE is the exam you might be doing. What is the TOEFL score? How many marks that person has scored in TOEFL exam? What is the CGPA of that person? How many marks he has got for his statement of purpose? If he has done some project work, and so on. So you might be knowing that GRE score is out of 320. TOEFL score is out of 120. CGPA is suppose on the scale of 1 to 10 is out of 10. Statement of purpose is on the scale of 1 to 5. Now let's suppose first person has got 320 marks out of 320. Second person has got 118 marks out of 120. CGPA is nothing but the marks in the year-wise marks or semester-wise marks. Suppose so this person has got 5 or 6 suppose. Out of 5 this person has got 2. And so on. 380 or 102 or suppose 8 or let's suppose 4 and so on. Now just try to check, are all these values on the same scale? No. Are all these values on the same scale? See, there is a difference. There is a lot of difference between 320 and 2. There is a lot of difference between 320 and 6. So all these columns, they are not on the same scale. That's why what we will do is we apply some methods which are called as standard. We apply some method and which is called as standard scaler. Now what this standard scaler is going to do? It is going to bring all these values to the same scale. What do I mean to say? See, if they are not on the same scale, what will happen is If you pass this data as it is to linear regression algorithm, linear regression algorithm will consider that GRE should be given more weightage as compared to CGP, right? Or TOEFL should be given more weightage as compared to CGP or SO. But what we want each and every column should be given equal weightage while training the model. So whenever I say standard scalar or whenever I say standardization, I mean to say to bring those values to the same scale. For as an example, let me show you what this standard scalar is going to do is, suppose it will apply some operation like it will take the square root of all the values. Suppose it will take the square root of first value, second value, this value, and this value. So square root of each and every value. Take the square root again and again till the difference between them is very less. Square root is the example I am talking about. Okay, you can go with the log or whatever. The standard scalar actually internally does same thing. Square root, do not confuse. Okay, square root is the example which I am saying. So make use of anything, but try to bring all those values to the same scale. Suppose by taking the square root again and again, finally we got the value as 0.8. Here we got suppose 0.2. Here we got suppose 0.1. Here we got suppose 0.01. Now the difference between them is very less. That means more or less they are on the same scale now. That means the weightage for them is equal, right? That means there is what we can say. It's not like that we are giving more importance to a specific column, a specific feature. If that is the case, then your model is going to be a biased model. But we do not want a biased model, right? So that's why this particular step is needed. Standardization. And normalization, I already told you, your data set should have a distribution like this. But if your data set is having a distribution, something like this, so that means there is some skewness present in your data, right? Or your data set might be having a distribution something like this. So there is a skewness in the data. So this is positive skewness and this is negative skewness, or we call it as rightly skewed data. This is left skewed data. So what is the reason for getting the skewness in the data? It can be because of outlier values, or it can be because of zero values. So we need to apply, or we need to remove the values which are responsible for skewness. How to do that? That we are going to talk about in the implementation itself, right? So here what are we going to do is we are going to use the methods like standard scalar. Basically, I mean to say that here we are going to make use of a package called as scikit-learn. Scikit-learn package I did not talk about because for almost all the algorithms which are mentioned in your syllabus, all the packages which are related for those algorithms are present in this scikit-learn. Scikit-learn, all the methods which are needed for that algorithm, like linear regression, logistic regression, support vector machine, k-means algorithm, KN algorithm, the methods required for all the algorithms are actually present in this particular package. So we call it as scikit-learn or sklearn. And that's why I did not discuss it separately. Okay. So normalization. How are you going to make sure that your data should be normalized? So we are going to remove the values or outlier values. Now who is going to tell us whether there are outlier values present in our data set or not? If you remember, we have seen something called as box plot. I told you, in case of box plot, it looks like this, right? It looks like this. So this is the outlier value. This is the outlier. So with the help of box plot kind of a plot, we are going to have idea about outlier values, and then we are going to remove those outlier values with the help of some method which are available in case of scikit-learn package. And that's how we are going to make sure that my data is going to be standardized, my data is going to be normalized. And then I'm going to go with the implementation of the algorithm or training of the model. Right? So standardization and normalization. That's what we do in this particular step. After that, creation of train and test data sets using optimum parameters. Now basically what happens is, let me talk about that training and testing step. See, initially suppose we have a data set. I will take the same example. Let's suppose in this data set we have 500 number of records. Now whenever I say that we divide our data into training and testing, what we actually do or how we actually do that? Basically, before dividing our data into training and testing, we divide the data into input and output. So I told you, input there will be more than one feature, and output there will be only one feature. Okay. So what is the input and what is the output? I will say. Suppose if I want to create a model, let's take the same example: GRE score, TOEFL score, CGPA, right, and so on. And finally, we want to do what? We want to predict the chance of the student for getting the admission in a foreign university for MS. So in this case, this is our target column, output column, explained variable or label or dependent variable. And all these are going to be our input features or explanatory variable or a feature. So initially what we do is we are going to assign all these things to X variable and this thing to Y variable. So always remember, output variable is going to be only one column, only one variable. But input is going to be more than one. That is multiple linear relation. Okay. So we are going to divide this into input and output. Input generally represented with X and output is generally represented with Y. Now this input and output, obviously if there are 500 number of records here, obviously there will be 500 number of records here also and there will be 500 number of records here also. After this point we actually do training and testing split. So we divide this data into training and testing. So this data will be divided into training and some part of the data will be test data. Similarly, some part of this data will be training data and some part of this data will be testing data. So I told you 70-30 is a general practice we follow, but it's not a hard and fast rule. It can be 80-20, 25-75, whatever it is. Let's suppose I am also dividing my data into training and testing, maybe in the 70-30 manner. So 70% of data, 70% of this 500 is what? 350. So 70% is training and 30% is testing. 70% is training and 30% is testing. So how many number of records I am going to get for training? 350. Similarly for testing, here 150. Similarly here for training, 350. Similarly here for testing, 150. Now try to understand. This is input and this is output. Okay. Now, so we are going to name it as X underscore train, X underscore test, Y underscore train, and Y underscore test. So my original data is now divided into these variables: X train, X test, Y train, and Y test. Now after this point, why we have done this? So after this, the actual training is going to start. Now you know that from training data itself, we are going to create the model. So that means this X train and see this X train and Y train. X train is the input training data and Y train is the output training data. Okay, so this particular data, this one and this one, this particular thing we are going to pass it as an input to, in our case, suppose linear regression. Right? This X train, sorry, this X train and it should be Y train. See, X train is input training data and Y train is output training data. So X train and Y train we are going to pass the input to linear regression, which is going to give us a model. Let's suppose the model is M. Okay. So we created the model. Now there is a time to test the model. So how are we going to test the model? For that, we are going to pass this input testing data as an input to this particular model. Input testing data as an input to this model. Now, this model is going to predict what? This is going to predict the chance of admission or output, I can say, or I will name it as Y predicted. So this is the result which is given by our model for this input testing data. But what is the original output for this input testing data? This Y test. So the difference between Y test and Y prediction is going to be what? Error or the percentage. This is what is going to happen. This is what we are going to implement in training. This is the actual whole process. Whatever I talked about is this is about how we divide our data into training and testing, and how we train the model and how we test them. That's why we divide our data into training and testing. I hope it is making sense to everyone. If there is a doubt, you can ask. Okay. After this, now once your data is divided into training and testing, so creation of training and testing data sets using optimum parameters. Then model training using machine learning algorithm. As this is our first algorithm, obviously, I'm talking about linear regression only. So select a algorithm. Again, selection of algorithm is also a trial and error. Generally, always remember, we never use only one algorithm for creating the model. We use at least 6 to 7 algorithms to create the model. Because whatever linear regression can do, same thing can be done with other algorithms with much more accuracy. Linear regression is a very basic algorithm. Okay, let me tell you, even we do not make use of linear regression and logistic regression in real-time problems many times. They are obviously they are very very useful and important, but that's what I'm talking about the real-time scenario. Okay, so once you have your training and testing data set ready, then we go and we apply a proper algorithm on that particular data set, proper machine learning algorithm or linear regression algorithm, and then we go and we train the model. And then we calculate the model accuracy both for training as well as testing data. And if you feel that the accuracy is low, to increase the accuracy, there is something called as hyperparameter tuning, which we will talk about at the time of implementation once our model is done. Okay, we'll be talking about hyperparameter tuning. So this is where you are going to use the concept of cross validation, which is mentioned in your syllabus. That's why I said that I'm talking about cross validation later on in linear regression itself. So hyperparameter tuning is like, suppose you are getting 60% of accuracy, but you are expecting 80% of accuracy. So you will go and once again you will try to change the parameters of your algorithm and then see whether it can be improved or not. So hyperparameter tuning formula is a signal for that. It is something which is going to help you to improve the accuracy of the model. And once you are satisfied with the accuracy, you go and you save the model. Now, how to save the model? So we generally make use of a package called as pickle. Generally, we save the model with this extension .pickle. Why to save the model? Because once you save the model, you can make use of that model in any project, wherever you want, on any machine you can make use. That's why I said earlier that I will be showing you how to create a web application. Even you people only sitting at your home, you will be able to make use of my application to predict the chance of admission of a student for MS. And you will get to know how we do it in real time. That's what I wanted to show. Okay? How to create a new application. And as I will be deploying that particular application on the cloud, you might be at any place in the world, we will be able to make use of my application. Okay? So .pickle file for now you just imagine it as .exe file, executable. So how to create that? That you will see. For now, you just remember that we always save our model with .pickle extension. There is one more extension that is .save also. But yeah, this is what we will be making. Once the model is saved, then generally what we will do is we deploy that particular model onto cloud. Deploy the model onto cloud. So for deploying the model, again there are different cloud platforms. Some of you might have heard about Amazon Web Services. There is Microsoft Azure platform, which is given by Microsoft company. This is given by Amazon, this is given by Microsoft. Then there is something called as Google Cloud Platform given by Google company. There is something called as Pivotal, which is given by a company called as Cloud Foundry. And then there is something called as Heroku. Heroku is a product of a company called as Salesforce. Some of you might have heard about Salesforce. So Heroku, so all of them they are free for 1 year. But if you talk about AWS, Azure, GCP, Pivotal, you need to give credit card information if you want to make use of those cloud platforms. But for Heroku, credit card information, debit card information is not necessary. All these are free for 1 year. Heroku is free for 2 years without giving any credit card, debit card information. And you can deploy 5 applications at a time on Heroku. And all others you can deploy only one application. That's why we will go with this free version. Okay, I'll be showing you how to do that. And once deployment is done, you can go with production activities. I'll be talking about testing that particular. For example, production means what? For example, just take example of WhatsApp. Now WhatsApp is in production now because in real time they are using WhatsApp. I mean to say it is in production. So if there is any problem with that particular with the working of WhatsApp, so how to do that? That's what this point is talking about. Finalizing about the retraining approach. Many times there is need to retrain the model. So it all depends on the domain. If there is a need, that will be decided by the client and the developers. And then logging and monitoring, and finally creating the dashboards for the analysis and the reports. Right? So this is a complete life cycle of any machine learning model. This is the complete life cycle. More or less, you are going to find out same thing. So who are the people who are going to work here? So data analysts, right? Or data scientists, machine learning developers, programmers, testers, all of them need to be, all of them will be involved here in this process. So this is all about machine learning lesson. Maybe in the next session I will try to show you the implementation of linear regression. Yeah, let's try to complete that. Okay. So anyone, any question till this point? Any doubt you have? Anything you have not understood? Just let me know. Otherwise, I will stop. Yes. Anyone? Any question? Okay. Okay. No problem. Many people are saying no. Okay then guys, we will stop here. So send your seat numbers and names in the chat box and I will end it. Okay, I hope everyone is done. So okay then all of it. We will meet in the next session. Let me know if you have any doubt in between.